You're going to have to listen to my voice go over this lesson. Okay, so today's lesson is basically we're going to be creating a confidence interval. So our confidence interval is going to be based upon what proportion of the earth is covered by water. And we're going to invest this question by taking a random sample of locations on the globe. So because I'm not there, we unfortunately can't do this as a class. But the idea is that we would take 50 samples. And then how many locations were water of these samples? So the idea is we would randomly pick spots on the globe and determine if we landed on a spot that had water or not. So in our case, 35 ended up being a location that had water. So next is we're going to calculate the proportion of locations from our sample that are water. So this is our p-hat value. So we're going to have 35 over our total of 50, which is about 0.70, so about 70%. So what we're going to do next is we're going to construct a 95% confidence interval, and we're going to estimate the proportion of earth that is water. So the first thing that we want to do when we create a confidence interval is we want to state. So what we're going to do is we're going to state the parameter that we want to estimate and the confidence level. So remember, the parameter has to do with our entire population. So our parameter is going to be P, and that's going to stand for the true proportion of earth covered by water. The confidence level that we're using is 95%, as it is stated above. The next thing that we're going to do is we're going to plan. So we're going to identify the appropriate inference method, and we're going to check the conditions. So the procedure that we're going to do is called a one sample Z interval for P. Okay, so it's called one sample because we're taking one sample, being the 35 out of the 50 that we got. Z interval, because remember we're taking that Z critical value of 95%. And P, because we're looking for proportion. So next what we're going to do is we're going to check our conditions. Can you think of the conditions that we're going to use? First one is random. All right, so we want to check that it's a random sample. So in this situation, we randomly selected locations on Earth. Next, what we're going to do is large counts. So remember, with large counts, that's us taking our n times our p and our n times 1 minus p and seeing if these both are greater than or equal to 10. So for our n times our p, that's 50 times 0.7. All right. And we get 35. For our n times 1 minus p, that's going to be our 50 times 0.30, which gets us 15. So both of these are greater than or equal to 10. So our large counts condition also applies to this situation. All right, so next we are going to do. So if the conditions are met, we're going to perform the calculations. So something that I want you to write every time is the general formula, which is going to be our point estimate plus or minus our margin of error. Next, what we're going to do is we're going to input our specific formula. And this is what we were doing the other day when we were doing the Hershey Kiss Lab. So we have our p hat, which is our sample, plus or minus our Z critical value times our standard deviation, which is our p hat times 1 minus p hat over n. All right, I'm just going to move this over here. so it's not as in the way. All right. So now all we have to do is plug the numbers that we have above into our formula. So our p-hat value, remember, is up here. All right, that was our sample, so that's our 0.7. So we're going to go 0.7 plus or minus. Now we can find that Z critical value. We're looking for 95%. You can look on that chart that we wrote down yesterday. The Z critical value for 95%, remember, is 1.96. So that's what I'm going to use here. So I have 1.96 times, and then I have the square root of 0.7 times 0.3 divided by our n, which is our sample size of 50. So I'm going to go ahead and I'm going to simplify this bit right here. And then I'm going to have 0.7 plus or minus 0.127. All right, and so now what this is going to do is that it's going to get me my confidence interval. Okay, so we're going to take this, and I'm going to go 0.7 minus 0.127 and 0.7 plus 0.127. All right, and then this is going to get me my interval of 0.573 and 0.827. So my answer, I'm going to just write it over here, is that interval that we calculated, like so. Okay, so lastly, we are going to conclude. And this is that script that I've been having you write out. So we are 95% confident. All right, remember this 95 came from up top. This is something that we plug in. All right, so 95% confident that the interval from 0.573 to 0.827 captures the true, and remember we're doing proportion, so it's the true proportion of Earth covered by water. Alrighty. And so remember also with this is our interval that we plug in. Proportion is the parameter that we care about. And then Earth covered by water is our context. Okay, so the important ideas from this section included our 4-step process. So our 4-step process was state, plan, do, and conclude. So what we state is our parameter and our confidence level. Our plan, we name our procedure. And we state our conditions. Our conditions being random and large counts. Our do is we implement our general formula, and that is our point estimate plus or minus our margin of error. Then we put our specific formula where we plug in all our numbers. And then we plug in. Lastly, our conclusion is we interpret our confidence interval. All right. So, I will have the key posted for the Check Your Understanding, but essentially you're going to be doing the exact same thing. All right. So what I will help you with is I'll help you identify what you need to know. So many kids aren't getting enough sleep, and a TV might be part of the problem. Among 2002, so this is our N value, that's our sample size, 2002. Among 2002 randomly selected 8 to 18-year-olds in the United States, 71% had a TV in their bedroom. Construct and interpret a 99% confident interval for the proportion of all 8 to 18-year-olds in the United States who have a TV in their bedroom. So this 71%, that's our p-hat. Our proportion is our parameter. And 99% is our confidence level. So that means that our Z critical value for this one is going to be 2.576. So the idea with today's lesson is that you should be able to complete this whole state plan do conclude situation every time they ask you to construct and interpret a confidence interval. All right, so go ahead and see if you can replicate here what we did up there. Good luck.